Greetings. In this one, we'll be talking about the class equation. So it says that the order of a group is equal to the order of its center, which are all the elements that commute with all the remaining elements of the group. And plus, we add all the other conjugacy classes, the orders of all the conjugacy classes that are higher than 1. Because all the elements in the center of the group are members of a conjugacy class that they are themselves in, which has an order 1. So elements of the center are conjugacy classes of order 1, and the remaining conjugacy classes are order higher than that. So we add those as well. And the remaining conjugacy classes have the order equal to the index of the centralizer subgroup of the index of the centralizer subgroup of that particular member element of that conjugacy class inside the group G. So we get the amount of elements of a group by adding the amount of elements in its center to the amount of elements in each of the remaining conjugacy classes, because adding up all the conjugacy classes gives the number of elements. And then thereby we can sometimes use it to, for example, get the number of elements in the center of a group by knowing, for example, how many elements there are in the remaining conjugacy classes, or work with these numbers and devise one of them from the other ones if some are available, the rest are, for example, not available, and so we can use this for calculations. But to look at a concrete example, a very common group we've been using is S3, and this is permutation of 3 letters. I can say 1, 2, 3, or I can say ABC are the 3 letters. So perhaps that's what I'll use. So it has 6 elements, E, then 2 cycles, and 2 3 cycles. And so we know that the center in the case of this group is only the identity element. Only the identity element commutes with all the other elements, and it's not changed under conjugation. And the remaining elements are members of conjugacy classes of order higher than 1, of more elements than 1. Namely, we found before that the 2 cycles are conjugacy class on their own, and the 3 cycles are conjugacy class. You can check it one by one, take an element, conjugate it for the rest, and find out that AB, AC, BC stick together in a conjugacy class, ABC and ACB stick together in another disjoint from that conjugacy class, and only E is one member conjugacy class. So for the example here, we see that the order of the group G, we know it's 6 because we've listed 6 elements, because we've known all the elements, but let's recount it. It should be equal to the cardinality of the center, that's 1 here, because it's just E. And then add the conjugacy classes, whose number of elements is equal to the index of the centralizer subgroups for that corresponding members of those conjugacy classes in the group G. So basically, to that we just add the number of elements of the conjugacy classes of order higher than 1, which is this conjugacy class of order 3 and the last conjugacy class of the 3 cycles of order 2. So together it gives the 6, which yes corresponds. It is the number of elements in S3.